6.2, quadratic trig functions level 1. Think back to how we factored quadratics from Algebra 1 and Algebra 2. It says find all angles. Remember, it can be equal to 0, but it can't equal 360. That satisfy the equation. We're going to round to the nearest tenth of a degree again if we need to. First section is having like a GCF factoring problem, which means take out the greatest common factor. So picture again that this cosine of theta is an x. That's like having x squared plus x equals 0. Both terms have an x. You take out an x and have an x plus 1. Those are called the factors. So you can do it this way and then put your cosine back in. Every time you see x. Or again, I don't really mind having it. I kind of like just doing it on the problem. That's really up to you. So I could see that both of these have a cosine of theta to take out. That would leave me with a cosine of theta to make that multiply to b squared plus 1. And so then I'm going to get at least two different answers. So I've got, where does cosine of theta equal 0? You set each piece equal to 0 and solve. Whereas cosine of theta plus 1 equals 0. And so if you need your unit circle, that's fine. Or you can use your calculator and do second cosine. This is inverse trig. So where is the x value 0? That would be here on the y-axis. Here at a 90 or a 270, our x values are 0. So 90, 270. And then our next piece, we got to solve real quick. We subtract the 1 over. So where does cosine of our angle equal -1? Where's an x value of -1? It only happens here, and that's at 180 degrees. So you get 3 answers. 90, 270, 180. Order doesn't matter. So I kind of find these fun. Number 2. See how there's two terms here? They both have a tangent of theta, but nothing else that can come out. So I'll have tangent of theta times a 3 tangent of theta plus 1 equals 0. Split your two parts. So this piece is where's tangent of an angle equal to 0. This one, hopefully we're good enough to solve all in one step in our head. You're going to subtract the 1 over. So it's -1 divided by 3. So it's -1 third. Tangent of theta 0. That is where is y divided by x 0. That happens here at 0 degrees and here at 180 degrees. Okay, this one you're going to have to do some work to because I don't see a third for tangent. So we will inverse tan. I'm going to do positive a third. That's my reference angle. 18.4 degrees. Tangent's negative in quadrants 2 and 4. So remember, I'm taking 180 minus, and here I'm taking 360 minus. I'm not going to rewrite all of them, but you get 4 answers. So again, all of this should be a pretty easy transition since we were already doing this in the last unit. Then we have trinomial factoring. Remember, trinomial is having like something squared minus something x or plus and minus 10. And so we have to think of two numbers that multiply to make -10 that add to make -3. And so this last term tells you what your signs need to be. If this sign is negative, that means that it was a positive times a negative. And then it's subtracting. So I'd have to have -5 and a positive 2. That would FOIL to make x squared minus 5x plus 2x, which is -3x, and -5 times 2 is -10. So you could do it that way and put your cosecant back in. Or just picture those being like that and saying, okay, this was a cosecant of theta times a cosecant of theta. What multiplies to make -10 that adds to make -3 is our -5 and our positive 2. So now you take each piece that I'm equal to 0 and solve. So this is cosecant of theta, Add 5 to 0, so that's 5. And then this is cosecant theta, subtract the 2 over, so it needs to equal -2. Okay, but remember when these are one of those reciprocal functions, go ahead and reciprocate both sides of the equal signs. That would become sine. We're going to flip 5 to be 1/5. So this is okay. This is in the range of sine. And then this would be sine of theta needs to be -1/2. So I'll definitely have to just do inverse sine on this piece. That is 11.5 degrees is my reference angle. And sine is positive in quadrants 1 and 2. So 11.5 is an answer. 180 minus 11.5 is an answer. Gets me 168.5. And then sine of -1/2, that's actually on my unit circle. Where is y, -1/2? I see it right here at 330, because that goes with a 30-degree reference angle, and I see it here at 210. So I don't care how you get the answers, get them somehow. Using all your resources, other than cheating, of course. All right, and then number 4 is very similar to that. We've got sine squared of theta. So that means a sine times a sine got multiplied. What multiplies to make 5, that adds to make 6. Would be a +5 and a +1. This one, if I isolate sine of theta, that would equal -5. This one would be -1. This is a problem. Since it's a sine, it can only be between -1 and +1. So if I try it, it's going to give me that error. So this one has no solution. That's out. Sine of theta. Where is y? -1. We've had this a couple times now. Only down here at 270 degrees. So I like that one. And the last thing is a difference of squares. That's like having 25x squared minus 9. Remember, difference of squares has 2 terms, subtraction between them, everything's perfect squares. So that's saying what times itself made 25x squared would be 5x times 5x. What times itself made 9? +3 times a -3. And then it makes the middle terms cancel out. So in this case, it would be 5 cosine of theta times 5 cosine of theta, and then +3 minus 3. And so if I solve for cosine, I get -3/5. And then here, I would add 3 divided by 5, I get +3/5. And so 3/5 is not going to be on a unit circle. We're going to have to do second. Cosine, I'm just going to do 3/5 in general, is a reference angle of 53.1. So what's kind of neat on this one is, since they're the same reference angle, I'm going to find that in all 4 quadrants, because it wants it where cosine is positive, which would be 1 and 4, and where it's negative would be 2 and 3. So let's see, we'll have that normal angle in quadrant 1. In quadrant 2, I take 180 minus that, 126.9. In quadrant 3, I add it to 180. And then in quadrant 4, I take 360 minus 306.9. So I get 4 answers. Okay, I want to show you something else you could do. Is just solve this by difference of squares. I could isolate the cosecant squared by adding 1. Dividing by 25. Don't make it a decimal or anything, just keep it 1/25. To make cosecant not be squared, I want to square root both sides. That will leave me just cosecant of theta. But remember that when you square root in an equation, your answer could be positive or negative. It needs to be both positive and negative versions. Square root of 1 is 1, square root of 25 is 5. So squaring a fraction, you just square root both numerator and denominator. So really this is saying, where is cosecant of an angle positive or negative 1/5? Well, let's go ahead and reciprocate that, and that says that sine of an angle needs to be positive or negative 5. That's out of our bounds. That's not going to work. So we'll say no solution.